All right. All right. Hopefully that fixes it. Anyway, we're going to be doing day 1 of 2025. I've not yet done it. I did day 2 earlier this morning. So if you want to see that one, you can go ahead and check out the live stream. I did do it in C. But I already read it too, and you can read the story if you really want to. You're basically saving Christmas each year by solving puzzles and getting stars. The puzzle for this first one, though, is let's see, where does it start? All right. So the attached document, your puzzle input, contains a sequence of rotations. So what you're doing is you're trying to open up a combination that tell you. Yeah, there we go. Okay, it's fixed. All right, so you're turning this dial either left or right, and that's what the input is, L or R. And then you're turning it a certain number of a distance, basically, numbers. So, for example, if we just jump down here, if you turn it L 68, then you're turning it 68 numbers to the left. If you're doing R 48, then you're turning it rotationally 48 numbers above or to the right. And it's cyclic, so it goes from 0 to 99. And so if you go from left to 0, then that goes backwards. If you go right from 99, then that makes it 0, right? So it's kind of like instead of overflow, underflow, it goes from 99 to 0, and then 0 to 99 if you go the other way. So if the dial were pointing at 5, a rotation left by 10 would cause it to go back to 95. And the dial always starts at 50, okay? So if we follow those instructions, what we want is the number of times that the dial is remaining pointing at 0, right? And so it starts at 50. You can see 50 is like down here. And so we'll turn it left, turn it right, turn it left, maybe left again, whatever. And how many times we cross that 0 at the top of that dial, okay? So if you've got this sequence, then the dial starts at 50. Then it rotates left to 68. That would end up at 82 because if you go back to 50, that goes back. You're going left, and so it goes down to 0. Right? You're going left. It goes up to 0. If it depends on how you want to look at it. And then 18 more would be 82. Okay. And then left 30 would be now 52. And then 48 we would then point, or R48 would then point to 0. Right? Is that right? Yeah, because we go right 48. So 52 plus 48 is going to be 100, but remember it's 0 through 99, so we'll end up back at 0. All right, are we good on that? Otherwise, we'll fix it as we go along here. I have chosen to start from scratch here because this. My point is not to solve these things. My point is to solve these things by doing a review of C. All right. So if I'm going to start out with a blank program here, what I want to do is, of course, an author header, right? But I'll leave that to you, right? And then, of course, I'm going to include the standard library, and I'm probably going to be doing input-output stuff, so standard input-output library. Right? And any other libraries, I'll come back and add those later on. Right? Otherwise, I've got my main, int argc char ** argv. I'm not going to be reading in any command line arguments, so I could have technically skipped that, but I will go ahead and put it in there because it's our standard boilerplate, okay? All right, so now the actual input here is very large, right? So it's huge, right? I don't know how many lines it is, but it's that many lines, right? We're never going to be able to do this by hand. We could do this one by hand, but I'm going to actually use that as my testing, right? So I don't want to just jump into the actual solution and guess at it and hope that it's correct. I want to use that actual test to see if I can get that one correct first. So what I've done is I've put this into a file called advent01 day1 input.test. What I now need to do over here in my program is I need to process that file because eventually I'm going to have the full input, which is this stuff right here. Right? And when I cut and paste that, there's 4,147 rotations. Okay, so let's go ahead and get rid of that. For now, we'll come back to it. Right? I need to process the file, so that means I need to open the file. And that means I'm going to have an input file pointer. How do I open a file for processing? Open. And I'm going to open up the file. Right now, I'm going to open up advent01.input.test. Right? Later on, I'll change that to the full, and then we'll get our actual answer. And I'm going to be opening this up for the purposes of reading R. Right? Error handling, error handling, error handling, right? I'm not going to do all of that, right? But if I wanted to do error handling, I would check for null. And that means that I ended up not being able to open up that file. I'll echo an error message here, right? Unable to open file, right? And end the line, and I would exit at that point because I'm in the main, okay? Otherwise, I've successfully opened up the file. What I want to do is I want to process it line by line by line. And then once I've got that line in, I can look at, oh, that's a left rotation or a right rotation, and then I can take the number and process that number, okay? So how do I process that line by line by line? First of all, I need a string to read that line into, right? And we usually call this a buffer. And I'll make it of size 100 because there's not a single line in here that's ever going to be more than 100 characters. Yeah, go ahead. Thank you. Mistyped? Thank you. All right. So I've got my buffer here. How do I read in that first line? Get s, f get s, right? And I'll read it into the buffer. And there are actually 3 arguments here. What's the second argument and what's the third argument here? The third argument is easy because that's your file that you're reading in from. What is this argument right here? The maximum number of characters to read -1 or +1. Why? It's going to read at most 99 characters because it's going to insert that null terminating character for you. All right? So that means that I've read in the first line. If I wanted to read another line, it would be the second line, the third line, the fourth line, the fifth line. I don't want to, of course, hard code that because I don't want to copy paste that 4,000 times for the actual input. So I'm going to go into what kind of a loop? A while loop, right? Oops, there we go. So while you have not reached the end of the file, right, read the next line. Forgets buffer 100f. Now, how do I know that I'm done? What does f get s return? It returns null if I'm at the end of the file. Otherwise, if it's got, I'll call this a line. Right? There we go. And while line is not equal to null, then I will continue. Right? I have remember the while loop. The initialization happens before the while loop. The continuation is right here. I continue until I'm at the end of the file. And then the update is done at the end of the while loop here. And because it's not a simple I++, right, it's going to be a function call here. Right? I, of course, could print these out to make sure that it's working. Line is equal to, or buffer, let's say, buffer is equal to %s and the line, buffer. And let's go ahead and gcc advent c and run it. And we see, I got into an infinite loop at L82. I did read to the end of the file. What's wrong? Yeah, what's wrong with my update here? How do I do it up here? I capture the line because that's what I'm. Oops, that's what I'm checking to see if I should break out of this while loop. So I never capture that value. So what should it have been? Line is equal to. Good. Now, when I run it, I get all the way down to 82. So there's my lines. Now, instead of just printing it out, we actually need to process it. Right? So 1, I need to determine if left or right. Right? And then 2, I need to capture the numeric value. Right? Okay? So the first one is pretty easy. That's just a single character, right? So if I call that direction, I can go ahead and get the first character of the buffer, which was going to be buffer sub 0. That's always the first character. What about the, I don't know, let's call it number, right? So that's the direction left or right. And then how do I get the number there? What if I did this? Well, first of all, how do I convert it over to an integer so I can start adding or subtracting? A to I of buffer sub buffer, like that. What's that going to do? That's going to look at, let's look at this. It's going to look at L68. It's going to start processing at the beginning of this string. Is L a valid number? Nope. So what have I processed so far? 0. What I want to do is I want to start at the second character. I want to start at buffer sub 1, right? Because that's where it's either L or R. I've already skipped it over that and gotten it out into this character called direction. But the problem is, what type is, well, first of all, what type is buffer? It's a character array. It's a string. So what is buffers of 1? It's a single character. Can A to I take a single character? No, it takes a string. So how can I take this character and turn it into a string like we did with substrings? Ampersand. Good. Right. And now let's make sure that it works. Printf. Rotate %c by %d, end the line. And so let's go ahead and rotate the direction and the number. There we go. And let's see if that worked. There. Rotate left by 68, left by 30, right by 48, left by 5. All right. I'm convinced that this is correct. Right? That we're reading in the input correctly. Now what I need to do is go back in here and remind myself of what we're doing. I'm going to be starting at 50, and then I'm going to be rotating left or right, depending on the direction and the amount. So let me go ahead and have a position here, int position. And I'll start it out at 50. Right? Now, I've got the number and the direction. Instead of printing it out, I'll go ahead and keep that just in case we need it. Right? I need to add or subtract. Right, so position plus or minus, right, by direction, or no, sorry, by number, right. So let's come back over here and remind which one should I be doing? If the dial starts at 50 and then we rotate left by 68, is that going to be adding or subtracting? It's going to be subtracting, right? So if the direction is equal to uppercase L, then we subtract. Else, if the direction, let's just make sure that it's actually correct. Else, if direction is equal to right, I will add. Right? What's the only other possibility? Something went wrong, right? So printf error, right? Error. Right. It's kind of a sanity check. If that ever actually does happen, we'll come back and find out why it happened. Right? But I don't think it's going to happen. All right. So if I subtract, position is equal to position minus the number. Is there a way that I could minus equals? We'll understand why I didn't do that initially in a second here. But position. But if that's all I had, then yeah, I would go minus equals. Equals position plus number. Okay? There. All right. But what's that going to do? Let's go ahead and restore this print statement. And let's go ahead and add, I don't know, printf now at position %d and the line position. Right? So GCC this and run it again. Right? There we go. All right. Rotate L by 68. Now I'm at -18. Is that valid? I should be at 82, right? Okay. So if you're going back, or let's go forward here. If you're putting the dial up and you go from 50 to 150, where are you really? You're back at 50, right? So how would I do that for the plus over here? I want to make sure that this is always between 0 and 99. So what operation would I do? Yeah, mod 100. Right? Likewise, this one, I'm going to try to mod by 100. Right? And I forget how C handles this, but I think that this is still not going to work because of how C handles it. But let's find out. All right, so GCC this and run it. Come on. There we go. I'm still getting negative values. Most programming languages won't do this. Like if I did this in Java or even if I did this in Python, it would wrap those negative numbers back down around to their positive equivalents. So 18 mod 100 would end up being at 82, right? It would end up wrapping back around to the positive value. C doesn't do that. C allows negative remainders in its modulus function, right? So what happens is, let's go ahead and add 100 back into it. That will be my solution for how C handles this stuff. So let's come back up here. Rotate L by 68, you're now at 82. Is that correct? 82. 52, 0. So now you're at 52. Now you're at 0. 95, 55, 0. 95, 55, 0. Right? Now remember what we're trying to do is we're trying to count the number of times it ends up at 0. So I need to add more code to do that. Right? If the position is equal to 0, then num times at 0. Right? Let's just go with a counter plus plus. Right? That means I need to create that counter before I start. Very basic question from week 1. Is that correct? No. What value is stored in counter without initializing it? Who knows? So 0. Right? And at the very end, I'm going to go ahead and get rid of that now for now. And at the very end of all this, I will say printf ended at 0 %d times end line. And that was a counter. And that's all I really want to print out. I ended up at 3 times. And that is correct, at least according to the test here. Now, what if I switch this over to the full? Now, remember that there are 4,147 of them. It's going to be very, very difficult to debug that test. But let's go ahead and try it. GCC a.out. 1,011 times. Now, if you've never done this before, if you get it wrong, they'll throttle you and you won't be able to answer for another minute or so. And then it's 2 minutes or something, right? Because there is an element of quickness here. There were, at least at one point, there were leaderboards. Okay, I'd have to join a private leaderboard. It's private now. But let's go ahead and see if I got it. Hey, we got the right answer. Right? So I earned a gold star, but now there is a part 2. For every day, there's a simple, not a simple, they get more difficult as you go along in the Advent calendar, but there's always a gotcha second part. That if you did the first part correct, it's only a simple extension. But if you did the first part incorrect, or you did it in a badly designed way, sometimes it makes it almost impossible without going back and redesigning your first solution to solve the second part. I've never read this, so we're going to have to read this together. You're sure that that's the right password, but the door won't open. You knock, nobody answers. You build a snowman while you think. As you're rolling the snowballs for your snowman, you find another security document that you must have fallen into the snow. Due to the newer security protocols, please use password method, blah, 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 until further notice. So again, it's just a story. You remember from the training seminar that method means you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during the rotation or at the end of one. So you don't end up at 0, you passed 0. Or you passed it again, you passed it again, you passed it again, right? Following the same rotations in the above example, the test example, then we would have passed it once. We ended up at 0. We passed it once, 0, 0, once. So in total, all 3 plus 3 is going to end up being 6. Be careful if the dial were pointing at 50, a single rotation like R1000 would cause the dial to point at 0 10 times before returning back to 50. Okay, let me go ahead and check the full input here. Do we have any like that? Okay, yeah, 560, 790. So it's definitely going to, it's thrown us for a loop here, right? I think I've got a solution though. Anybody want to suggest a solution though, before I say it? Yeah. Yeah. So if I did, no matter where I was, if I did 790 rotations, how many times would I have passed 0? 7, right? And then 90 might cause another one, right? Depending on where we started. So all you have to do is count the number of, divide by 10, right? And add that to your total. And then you still have to count whether or not you crossed it by, like if it was, we'll end up with 90 instead of 790 after dividing by 10, or by 100, sorry. And that would still cause a rotation past it. All right, so first of all, we can take care of that first one by, let's do a second counter here. Int rotation counter is equal to 0. And then what we can do with that number is we can say rotation counter plus equals number divided by 100. Is that enough? 790 divided by 100. Is that going to give me 7, like I said? Yeah, why? This is an integer, and this is an integer, right? And so it'll be 7.9, but what happens to that 0.9? Truncation thrown away, right? And then I actually need to divide by that. So number divide by 100. That now gives me 90, and then I can go ahead and go in that direction, right? But I still need to know if I passed 0 or not. How do I know if I passed 0 or not? Well, if I'm subtracting, all right, here's my old, let's go ahead and keep track of the old position. Int old position. Position is equal to position. Then we can update that position. Now, how do I know if the old position and the new position, remember I'm only going left, so I'm subtracting, right? How do I know that I passed 0 or not? If my old position is greater than the new position, then I passed 0. So what was my rotation counter plus plus? I'm just keeping them separate, and then we'll add them at the end, right? Now let's understand that. Let's actually, whiteboard this. I don't know. Let's suppose that I went from 25, and then I rotate left by 50. Right? I would have ending up at 75. Is that correct? Yeah. All right. So my old position is 25. My new position is 75. Ugh, is that the correct logic? Flip it. I like that better. And now the old position 75 is greater than the new position 70. And so what would it mean for going the opposite direction? Here, let's capture the old position here as well. Right. If rotation counter plus plus. Right. All right. So what's my position? What's my condition here? I'm going right, right? So if I end up in a larger, well, now I can't even do that, right?
If you end up
okay, smaller. There you go. It's just the opposite. Old position is greater than the new position, then rotation counter plus. All right, so once we've done that, ended up 0 that many times, crossed 0 that many times, and that's going to be the rotation counter. I have no idea if this is correct or not, but we'll go ahead and find out. At least it'll run, right? So those two added together is what I actually want, and I don't want to do the additions myself. Oh, I'm still on the full, so let's go ahead and go to the test to see if it's correct. Total, it's going to be %d, and I will just simply add these two things together. Counter plus rotation counter. I'm going to let it do that for me. Oh no. What happened? It opened the file. It was working before. I only want to divide it if it's greater than 100. What happens if it's 25 and you end up dividing it by 100? What do you end up with? 0, right? And that's why I ended up with 0 everywhere. So if the number is greater than or equal to 100, it can't be equal to 100 because I would have taken care of that right here, right? Then and only then will I divide it. Okay, that should fix it. There we go. Ended up at 0 3 times. I crossed it 6 times, total 9. That doesn't sound right either. So in this new, you end up, I end up double counting, I think. So if I just take this one, it's probably correct. All right. We'll find out. Well, otherwise I'll give up and let you do this on your own. All right, so run this. All right. It was 50 to... What was the old answer? 1011? I broke something probably. I should still be getting 1011 here, right?
Yeah.
I don't think I changed anything on that. All right. YOLO it. That's not right. Answer's too low. So I'll put that in the notes down here. All right. Too low. All right. So we screwed something up. I definitely screwed something up because we're not getting the same answer as before. Darn it. And I don't know. I don't want to think about it too much. Yeah, go ahead.
Wouldn't we also need a conditional if we rotated left by 100 or right by 100? Because that's...
We're doing that unconditionally right here, right? Yeah. So it doesn't matter if it's left or right. We end up passing 0 that many times divided by 100. Yeah, I'd have to think about it a little bit more. But we did day 2. Let's go back over here. We did day 2 this morning, and it's a little bit. I think it was a little bit more difficult than day 1. But the idea is that you are given all of these ranges, and note here that they are not necessarily sorted, right? And so then what you have to do is you have to find IDs within those ranges that are invalid. And what you do is the candidates here are digits that repeat themselves. So for example, 1 is 1 repeated, 2 is repeated, 3 4 4 5 5 9 9, and then the next one would be 10 is repeated, then 11 12 12. And what you have to do is you have to find out, do any of those numbers lie within any of these ranges, right? And I can show you the solution if you want, if you want to see it. Otherwise, I don't think that we definitely don't have enough time to redevelop it. But I can show Advent 02 here. All right. So here's some of the components that we put together. First of all, to model these ranges, what we did is we created a structure that created a lower bound and an upper bound. And note here, I'm not using an integer because immediately I can see from the input that, well, not any of these inputs, but the actual input that you're given. Here's a number example of a number, right? Is that going to fit into a 32-bit integer? What's the maximum value of a 32-bit integer? 2.147 billion and change, right? This is way too big. But as you learned in your hack this last week, what can you use? Longs. Those are 64-bit numbers, right? Much, much larger. And that was good enough. What's another alternative? What did you actually use in your... You use longs. Those are 128-bit numbers, at least on our server they are, right? And those are going to be much, much larger, okay? And then what we did is we sorted them. What would a comparator like that... let's review comparators here. A comparator takes 2 const void star pointers and returns an integer based on the relative ordering of A and B. You always have the same pattern here, that you force those 2 generic void pointers to become the types that you want. In this case, it's going to be a range, right? So I forced it to become a range X and Y. And then I compare the lower values. If X's value is lower than Y's value, I return a -1. Why did I use a arrow here, the arrow operator? Because they're pointers to it, right? If they were not pointers, what would I use? The dot operator. Good. Otherwise, if it's the other way around, I return 1. The only other possibility is that X lower and Y lower are equal. And if they're equal, then I look at the upper bound here, and I make a determination based on the upper bound. Right? The same basic stuff here. I read these in. Actually, wait. There was only 1 line. And so what I had to do is I had to go through and count the number of hyphens and the number of commas. Because here is the input. Right? It's one big CSV file, comma separated value files. However, the ranges were then separated by hyphens. And so what I did is I used strtoc here based on either a hyphen or a comma here. And then I read in pairs each and every single time. I read in A and B, right, using strtoc, converted them over to X and Y. And how do you convert them? Well, if they were integers, it would be A to I, but these are long, so it's what is it? A to L, right? And then I set the lower and the upper bound to X and Y, and I counted however many there were, and then I sorted it. I sorted it because I wanted to make sure that there were no overlaps, right? I didn't check this in the actual program, but I did check it manually. This range and this range, what if they overlapped here? And you found an invalid ID that was in both of them. You don't want to double count that, right? You just want to count it once, right? I printed them out to make sure that it worked, right? And then I iterated over each possibility here, right? 1, 1, 2, 2, 3, 3, 9, 9, 1, 0, 1, 0, 1, 1, 1, 1, right? Et cetera, et cetera. I made sure that I never went past the maximum value. Where's the maximum value going to be? Because I sorted it up here. It's at the last one, and it's the upper bound on it. Right? And then so while I've not exceeded that maximum value, I check each range for that value, and I print whether or not it's valid or invalid, and I keep a counter and I keep a summation. Right? Now here's where the real magic happens. Where is it? Yeah, this is where the real magic happens. Right? How do I double the number? Right? So I've got I here. Right? How did I double it here? sprintf. Right? I printed it to a string twice. So if it was 1, 2, 3, 1, 2, 3, 123 and 123, I just printed it so that it was 1, 2, 3, 1, 2, 3. That's not a number, obviously, but you can always convert it back to a number using A to L from a string. Right? And so I just used this temporary string to do that. Right? That's how I was able to get all of the double numbers. Right? Yeah, and then we had an answer. It worked this morning. But if you want to, you can watch that live stream too. Right? We have a full solution, and they helped me out with it too. But we eventually got it. And then this afternoon, by myself, I went back and I did the second part. Have I done the second part? Yeah, I did the second part because I got my 2 stars. Right? Yeah, both parts of the complete. I did it at some point. And what did I? Oh, the twist here is that it's not just repeated twice. It can be repeated any number of times. So if I have 123, it could be 120, 1, 2, 3, 1, 2, 3, or it could be 1, 2, 3, 1, 2, 3, 1, 2, 3, or it could be 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? And I did that in Python instead because it was easier. Right? But you can repeat it 2 times. You can repeat it 3 times, 1, 2, 3, 1, 2, 3, 1, 2, 3, 5 times, 7 times, right? The trick here is to make sure never go past the maximum number, right? If this is the maximum number, whatever value you're concatenating, right? You might want to, never want to go past that, otherwise it'll take forever, right? Okay. So, if you want some practice or fun, or over the weekend or something, or over the break or whatever, I would highly recommend that go back to 2015. That first year was much, much easier than the subsequent years, right? The first year, I think that the first day is ridiculous. It's just add up numbers. Oh, no, it's that's not it. There's one, though, that was like add up numbers. I don't remember what they were. I haven't looked at it in a while. But they used to sell swag, and I got that swag that year. Oh, they still sell stuff. Yep, they still sell. They don't have the hoodie anymore, but they have T-shirts or whatever. There's the 10th anniversary. Yeah, I might get that. I don't know. That was from last year, though. All right, so what we'll do on Monday and Wednesday is I'll bring in last year's final. I'll bring in 2 years ago final, and we'll do those. If we want to meet on Friday, we can for a 3rd review. But again, remember that your exam is not going to be the same as in years past. It's going to be 33 multiple choice questions, open book, open note, written note, or printed note. You can bring whatever you want, but no electronic devices. Right? So, any questions? Oh, and then also remember, it'll be with the announcements, but in the Dead Week, next week, you'll have an opportunity to come to help hours and have 1 hack and 1 lab reevaluated if you want it. Right? Just like we did in that Fix It Week, Week 5, you'll be able to do 1 more lab and 1 more hack if you want. All right. And remember, no class of this Friday.